All right, let's take a look at the next point of concurrency. And it is the circumcenter. The circumcenter is the intersection of all the perpendicular bisectors of a triangle. This one winds up being a pretty easy construction because you can do it with just one single compass setting. So let's say we start with our triangle. In order to find the circumcenter, we need to construct the perpendicular bisectors of every side. So the easiest way to do this, if we wanted to find the perpendicular bisector of one side, I would start on the longest side, extend your compass so it's exaggeratedly beyond half the length of that, and then we're going to construct an arc. And now, if I duplicated this same arc from the other endpoint of this side, I'll be able to connect those and find my perpendicular bisector. Well, planning ahead, this point happens to be the endpoint of not just one side, but two sides. So what I'm going to do is, if you construct almost a full circle, or at least 3/4 of a circle, from every single one of these vertices, again, by setting your compass distance to the longest side, so you're at least half the length of that longest side, and then you construct, again, 3/4 of a circle in each of these. What's going to happen is you're going to create all three of your perpendicular bisectors with just those three markings. And does everybody see what I did there? From just construct almost, and you can even do a full circle from each vertex of your triangle, as long as it has the same radius. What you can then do is connect each of those using a straight edge. Okay. Here's my perpendicular bisector for this upper side. Here's my perpendicular bisector for the bottom. And then here's my perpendicular bisector for that far side. Okay. Again, do these confirm what I was expecting to see? Is the intersection of those three one single point? Yeah. So here is the circumcenter. Again, do you need that third perpendicular bisector to find this point? No. If you're in a rush, all you need to do is two of them. The third one simply allows you to confirm that you have the right answer. Okay. Again, this also allows you to construct a circle circumscribed about a triangle. And this is a very easy addition to this. You simply need to construct a circle that passes through any vertex of the triangle. Okay, so if you know that this circumcenter is the center of your circle, if you simply take your compass, place the compass tip at that center point, and then just measure the distance to any vertex. It doesn't matter which one, because if you've found the right point, when you construct this circle, it should pass through all three of these vertices. Okay. So again, I confirmed this is the circumscribed circle. It also allows you to inscribe a triangle within a circle, if you think of it from the perspective of the triangle. Okay, so the circle will pass through all three vertices of your triangle. And the other way to think of that is this point of concurrency is equidistant from all three vertices. Okay, so the distance from any of these vertices to that point are all equal, and they should be all equal because each one is a radius.